Look at this setup. Everything is running perfectly. The motor is on, the conveyor is moving, boxes are arriving, and our sensors are picking up every single one. Nothing seems wrong. Now, let's remove one tiny thing. The sensor fails. The conveyor keeps moving, but our controller, it has absolutely no idea where that box is anymore. The machine didn't stop because something physically broke. It stopped because it lacked the source of knowledge. If you were the controller running this line, how would you even know a box exists? You wouldn't. Controllers don't have eyes. They don't watch conveyors like we do. They only know what the sensor tells them. Everything a controller believes about the physical world comes entirely from electrical inputs. If there is no sensor, there is no information. And with no information, the machine is completely blind. When a box passes a photoelectric sensor and it lights up, it feels like the controller now knows where the box is, right? Not exactly. The controller doesn't know there's a box. It only knows that the electrical signal just jumped from 0 to 24 volts. That's it. It's just an input turning on. The controller has to construct the idea of a box purely from that signal change. Sensors do not tell machines what happened out there in the real world. They just provide electrical clues. It's the controller's job to interpret them. Let's look at 3 scenarios where things go sideways. Case 1. The sensor never turns on. Did the sensor fail? Or did the box just fall off the belt? The controller doesn't know. Case 2. The sensor stays on forever. Did the box get jammed right in front of it? Or is it the lenses just covered in dust? It's the exact same signal, but 2 totally different realities. Case 3. The sensor flickers rapidly. Is it a loose wire? Electrical noise? Machine vibration? Again, the controller only sees the changing inputs. The takeaway here is massive. The controller never observes reality directly. It acts like a judge in a courtroom. It can only look at the evidence presented to it. So, if the controller is blind, how does a machine actually know if something is wrong? It doesn't, at least not immediately. It has to start asking questions. Faults aren't just instantly detected, they are inferred through logic. When a signal comes in, the controller essentially asks, is this what I expected to happen right now? It's constantly comparing what actually happened against what should have happened. That gap between reality and expectation, that's where fault logic lives. Every time a machine takes an action, it starts a stopwatch in its head. Let's say we start the motor to move a box. The controller expects sensor A to light up within 5 seconds. Now, watch what happens if the box gets jammed. The motor is running. The controller waits. 1 second, 3 seconds, 5 seconds, still nothing. Eventually, the timer runs out and the controller concludes, something is wrong. Stop the line. Notice what just happened. The fault wasn't a broken sensor signal. The fault was a broken expectation. This brings us to the biggest mistakes beginners make when designing automation systems. Beginners think sensors directly detect faults. They don't. Sensors report inputs. Controllers detect faults. This is an enormous difference in systems thinking. One device just measures the physical world. The other device actually does the reasoning. If every decision a machine makes depends entirely on sensor information and comparing that information against time, what happens when that information isn't missing and isn't wrong, but just arrives late? That's what we are covering in the next video as we move beyond one machine and look at what happens when multiple systems try to talk to each other. See you in the next one.